Hello, I'm Roman. Welcome back to the series of videos Learning Go, where I'm diving into this official tour of the Go and going through all of the chapters, solving all of the exercises, and diving into the language. In the previous video, I had to stop earlier than I expected. I stopped on the exercise with the images, and that's what we're going to do. So I will reread it because I don't remember what it was. The picture generator wrote earlier. Let's write another one, but this time it will return an implementation of immediate image instead of the slice of the data. Okay. Define your own image type, implement necessary methods, and call pic.showImage. Bound should return an image rect. Color model should return RGB model. Edge should return the color, the value V in the last picture generator corresponds to this one, but I mean, I can do any one. So let's start writing. So the first thing we need to implement, actually, I think the old value receivers, right? So we have the image with color model that returns color model, and I need to import, I think it's image slash color. How I understood this, yeah, probably you do not see, but at the bottom, like there is a package.go.dev slash image slash color. So yeah, that's one of the ways you can understand this. And what we're going to return, we need to return the color RGBA model. I think that works, right? It should be just a const value. So we have the RGBA model. Yeah, it should be a const one. The second one is bounds. So we need to return bounds. We need to return the rectangle, which is the rectangle. And that should be width and height. We'll use it as an int. Basically, it returns rectangle of 0, 0. That's, I think the width and height goes first. And the last one is the actually generation. So there is an at I x and y int. There is no error, right? So it should return just color. Okay, and what do? We call the color. How we did this? Okay, and we actually need a way to generate how would do this? Picture generator. What I did here, I created some data. Okay, but I can do this. I can do this data by right? And that will return me, for example, if I want to make the RGB, so I would have different types of the red. So it will be RGBA, right? Then it will have the data at how I would do this. Now I would actually exactly I would generate it. So we have the what I want to do. I will have 250 this one, but I want to create the red. And how I would do this? I would do it like this. I will have the x plus. I'm curious what things I can do. Okay, x plus y divided by I width, not a height, and that should be float, and that will be float, and then we multiply it by 255, and then we truncate it, right? So it means that we have the width 100 and height 100, and see if I undefined color dot RGB model RGBA, because it's RGBA rectangle. Really? And where's the rectangle? Rectangle. I guess it's in the image. This one. Rectangle. Okay. Image imported but not used. Where I forgot this. Can't use 0 on typing constant as the image dot point value in struct literal 19. Okay. Where the point is defined, same. The image. Okay. Can I do this? Missing time in compose literal image dot point. Okay. Okay, so I would do actually this. Okay, yeah. But it's red. What it will do? I will do something like this. Yeah. Okay. Divided by 2 plus by red divided by 2. I need to okay, this is our image generator. I will do this. That will do. Okay, this is a little bit crazy. Yeah, but we can play around with the generation. Like, else I can do? Yeah, I think that's fine. Okay, I finished the lessons, and right now we go into the next. The next one is where type parameters. So we actually going into the generics, and this is where I think the interesting part will start. I think the generics are more or less new thing to the Golang. They been added not that long time ago. I mean, comparing to the existence of the language itself. Go functions can be written to work on multiple types using type parameters. The type parameter of a function appears between brackets before the function argument. So okay, so this is t comparable. So there is a function index. There is a type t which is comparable. I guess that's the interface, but let's see. So there is a slice variable s with the slice of the t, and there is x of the type t. This declaration means that the s is slice of any type t that fulfills the built-in constraint comparable. X is also at the same time. Comparable is a useful constraint that makes it possible to use an equal and doesn't equal operators on the value of the type. In this example, we used to compare a value of all slice elements until a match is found. This index function works for any type that supports comparison. So what do we have comparable? This one. So it is an interface. Oh, interesting. Comparable is an interface that implemented by all comparable types, boolean numbers, strings, pointers, channels, arrays of the comparable types. Structs those fields are all comparable types. Comparable interface may only be used as a type parameter constraint, not as a type of the variable. Okay, so basically I cannot use it as a type of the variable. Provides documentations for goals predefined identifier. The items documented here are not actually in the package built in, but their description here allows GoDoc to present documentation. Okay, so I guess, okay, the complex int. Oh. Okay, interesting. What are the other types? Okay, so the index returns the index of x in S or -1 if not found. So we have the index. Again, we have the slice of the type t's, and we have the t. Then we're going over the range. B and x are type t's, which has the comparable constraints. We can use double equal comparison. So if okay, index works on the slice of ints. Index also works on the slice of strings. So basically the same implementation. Okay, yeah. In addition to generic function, Go also supports generic types. A type can be parameterized with a type parameter, which could also be useful for implementing generic data structures. This example demonstrates simple type declaration for a single linked list holding a type of the value. Okay. As an exercise, add some functionality to this list implementation. Okay, let's try. List represents a single linked list that holds value of any type. So we have type any. We have the next. Oh, okay. So it's a little bit confusing. I mean, I would expect, usually you have something like this. I would not use it because you have the square brackets representing the accessing, or okay, in the map they do the same. Yeah, okay. But I can do comparable it's called. Where is it? Comparable. Would compile. Yes. for example, I have a type as struct that has, I don't know, intref, and since it's not implementing the comparable by default, okay, so I actually want to have two. I want to have S1 and S2, and then, okay, L1, which is the list of S1, right? Nil. Declare the missing type. Missing type, that will be S1. No, FMT. Entire lab. Well, define FMT. Okay, nil. Oh, so it's comparable. And I can do this, right? Declarated nest L2, can use S1. Yes, sorry. Can't use nil. That will be 0. Okay. Then how I can... Oh, maybe what I cannot do if it's not comparable, I cannot do lists of ints, right? Nil. Maybe that's what I cannot do. No, I still... Then I don't... Okay, well, that will work. Congratulations. Okay. Okay, so that was basically all of the generics. So there are actually two things. The first one is that you can define... By the way, can I add the interface constraint? For example, I have the type interface, which is the interface, right? And it should have, I don't know, some function. And can I do this? Will it compile? And then, for example, for example, S1 do, will it unexpected name do unexpected name do S2 doesn't satisfy I, missing method int does not satisfy I. Okay. So if I will remove this, it basically means that I can use interfaces as the constraint. Okay. Okay, so here comes the most interesting part, and this is concurrency. Goroutines, channels, and where to go from here. Okay, web size, web crawler, blah blah. Let's see. Let's dive into this. A goroutine is a lightweight thread managed by the Go runtime. Okay, so there is a Go. In the Go, you have the Go keyword, and there is a func. Starts a new goroutine running this function. The evaluation of f, x, y, and z happens in the current goroutine, and the execution of f happens in the new goroutine. So, for example, if I have some, I don't know, calling of the function, I don't know, something like I need to take a, a value from something else, it will be launched from the current Goroutine, but to get all of the params, but the actual running of the function should be run in the separated Goroutine. Goroutines run in the same address space, so the access to shared memory must be synchronized. Okay. The sync package provides useful primitives, although you won't need them much in the code as there are other primitives. Next slide. We have sync. Oh, okay. One func, one value. Okay. Package sync provides the basic synchronization primitives. I think that should be better. Once the once and wait group types most are intended to use by a low level library routines, higher level synchronization is better done via channels and communication. Values containing the types defined. Okay. Okay. So we have the function say that goes from 1 to 5, called the sleep, and prints this. And then we... Yeah, so basically it will be hello then world, because okay. It prints the word 5 times. So there is word hello. Interesting that the new launched Goroutine started to print earlier than this one. So we have word. I think this is always, I don't know, then the hello. So yeah, it's all usually you cannot rely, even if it's written in this way, and you might think that it should start printing earlier, like the first, and it's not like this. Channels are type conduit through which you can send and receive values with the channel operator. Okay, so there is a channel and there is a value, and you send the value to the channel. And with this weird thing, you receive the value from the channel and assign it to data flows in the direction of the error. Okay, then that's actually makes it easier to understand. Like maps and slides, as channels must be created before use. So there is a make channel and the type of the data that we're going to send. So it's type channels. Okay. By default, send and receive blocks until the other side is ready. This allows Goroutines to synchronize without explicit blocks or conditions variable. The example code sums the variables in a slice, distributing the work between two Goroutines. Once both Goroutines have completed their computation, it calculates the final result. By default, sends and receive block until the other side is ready. I don't fully understand this. Okay. Okay, so we have the numbers. We create in a channel. Okay, we create in a channel. Also, it's kind of, so then we launch one Goroutine, the second Goroutine, and it accepts the channel, right? So then what it does, it takes the slice, it iterates over, and then it writes the sum into the channel. So this is, and here we declare that we need to read two values from the channel. So I guess it's, so this is how it works, right? So basically these are the places where the synchronization is kind of happening. So Yeah, I have a couple of things to test. Yeah, -5, which is -5, -5, 17, and it's the total. So, okay, but what if I will do this? I think that should block the program because it will expect 3 values from the channel, and algorithms are asleep. Deadlock. What does it mean? What algorithms are asleep? Okay, so this. Okay. What if I will do this? Actually, that should be a deadlock too. Undefined y. That should never -5. No. So we actually just read the first value and we go on. But when the second coroutine writes into the channel, nobody reads it, and we actually do not expect it. Okay. But what if I will do this? I'm trying to lock it, and that should make a lock. Not a, yeah, deadlock. Okay. So basically, here's what's happening. We created a channel. We running only one goroutine, but we expect 2 output values from the channel. We never get it, and this is why we have the deadlock. Okay. Yeah, I mean, in some cases, yeah, it looks like you don't have to, there is no need to manually do synchronization between the threads, which is, I think it's a nice way. But I already feel that once I will start to use it, in the production or actually try to implement some code with this, I will have some troubles. Buffered channels. Channels can be buffered. Provide the buffer length and the second argument to initialize a buffered channel. Okay, so channel of 100 sends to a buffered channel blocks only when the buffer is full. Receives blocks when the buffer is empty. Modify the example to overfill the buffer and see what happens. Okay. Okay, so we define the number of the elements that the channel can take, and then we expect the same. What if I will do this? That should be a dead. No? Okay, what if I will do this? Okay. But with this one, channels are buffered. So I guess I can limit the number of the elements that can be passed through the channel. I cannot expect more. I guess I can read less, but I mean, should I mean, there are actually many questions. For example, I have the 10 here. I cannot read because, okay. So it means that I can send into the channel 8 more values. And if I'm going to read them, and I should read them. But I'm curious, if I do not send all of the 10 values through the channel, will the channel live until I don't know, manually close it, or until all of the values are passed? But I guess once I used all of the buffered values, like all of the 10 items, the channel most likely is closed, right? So, oh, by the way, can I print it? Just take a look what's happening. Okay. Okay. It's just a number. Oh, a sender can close the channel to indicate that there is no values will be sent. Receivers can test whatever channel has been closed by assigning the second parameter the receiver expression after. Okay, this was the occurs false if there are no more values to receiver and the channel is closed. The loop for I range in C receive the values from the channel repeatedly until it's closed. That's really nice. Only the sender should close the channel, never the receiver. Sending on the closed channel will cause the panic. Sending on the closed channel. Okay. Channels aren't like files, you don't usually need to close them. Closing is only necessary when the receiver must be told there are no more values coming, such as terminate a range loop. Okay, so maybe in some cases I want to, but can I do this? I mean, oh, okay, so it expects 10 values, but if I will do this, it will be this. Oh, so it goes for the number. Okay, so for the capacity, but what if I want to then 10? Will it be closed anyway? Okay, so I passed 10. It means that the n here is 10. We had the loop of the 10 iterations and then we manually close it. That means that so I guess I can do this and print the line. It should be false, right? Declare but not used. Send mismatched variables, but one false. Okay. So it means if I read the value, it should be garbage. Yeah, it's just a default value for the type. Okay. Okay. The select statement lets the goroutine wait on multiple communication operations. The select blocks until one of its cases can run, then it executes the case. It chooses one at a random if multiples are ready. Okay, what is happening? We have a channel, we have two channels. We have the channel C and the channel quit. We have the goroutine that goes 10 times and read from C channel. And once we get all of the values from the C, we are writing 0 into the quit. So we're indicating that we're done. All right, I guess. And okay, so, and then we call this Fibonacci with the C and can pass into two channels. Okay, so there is a select and there is an infinite loop. And while we okay, so we run the Fibonacci runs the there is an infinite loop, and then what we do, we read the value from C. So this goroutine, this goroutine produces the, wait, I'm confused. Data goes into direction. So we're actually reading from channel 10 times. So there is a, so, okay, so we place in a reader from the channel, then we check in that if there is a reader from the channel as a guess, then we calculate X and Y. But how do we return? Okay. Okay. So if there is a reader, then we post an X into this and we calculate the next one, and then we go 10 times. And once we pass the 10 times, we're sending but it will be waiting for all of the 10. So it's like one by one. Yeah, it's very unusual way to write the code. I think you just have to get used to it. But basically what I see here is there are kind of two threads. Well, top coroutines. The first one is reads. Reads from the Fibonacci. Like there is okay, let's call it main goroutine. This is the main goroutine actually, and there is a second goroutine that reads from the main one. The second goroutine, the main goroutine produces, like calculates the Fibonacci and sends the data into the channel. And the second goroutine kind of reads all of the values and it reads it for 10 times. So we expect 10 values to be presented. I can make 100 and that will be the same. Yes, I can do 0. It will be 0. With 5, it will be 5. So we expect here 5 reads from the channel. And okay, and we actually do not close it, right? So there is a sender, but curious. I think we should. I mean, we can do this, right? So close this and close quit. So we actually close this channel and we cannot use it once again. I think that should fail because the channels are closed. Yeah, close of closed channel. Okay. Oh, actually, I need to duplicate this, right? Close of closed channels. Okay. Wait. Oh, they will be at the same time. Okay. Oh, it ran the Fibonacci. There is a 4. Wait. Println. Send on closed channels. Yeah, this is what I expected. So we're running the Go routine, and then we call in the Fibonacci, and the Fibonacci tries to send the data in the channel that we closed before, and this is why we have this error. Okay, what's the time? Oops. Okay, where are we? Okay, so let's read for the default selection and equivalent binary trees. Interesting, there are 2. And I will stop for day, so the information will sink in, and next time I can start from the exercise. Default case in a select is run if no other cases ready. Use a default case and try to send or receive without blocking. Use I, receives from C with block. Wait, default. Okay, use a default case to try to send or receive without blocking. Try to send or receive without. be honest, I'm not sure what they mean. Without this one? Um, hmm. But I guess I need to just wait, and that will be wait. Case. No? No. Tick, 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 boom. Okay, I will revisit this next time. Receiving from C would block. What is? Okay. Receiving from C block. Yeah, I don't understand what it means. Okay, I will revisit and maybe take a look what they mean. Yeah, okay. Thank you for watching and I see you tomorrow. Bye bye.